So today I'm going to tell you about imaginary numbers. Now, the word imaginary might not be the best choice for the name of these numbers because they're not fake. They just are not in the same group as the quote real numbers that you've been working with. So, so these imaginary numbers are numbers that do exist. They're just different group of numbers. So to start, the reason we need them is because we can't square root -1, right? Because the square root is asking for the number that multiplies by itself to get this number, such as, the square root of 9 is 3, because 3 times 3 is 9. But if you try to square root -9, it's not going to work because 3 times 3 is positive 9, and -3 times -3 is still positive 9. So that's where this imaginary number comes into play. So the definition of the imaginary number is the square root of 1, -1, is equal to I. This is the basis of all of these. What this means is that if you square I, you would get -1. So what this implies is that I squared is equal to -1. Previously, if you square any real number, you're going to get a positive number. But if you square I, you get -1. Okay, and that's going to be really, really important for most of the problems that we're looking at. Now, when you're just adding and subtracting I, it works just like a regular variable. So like number 1, you have this, they call these complex numbers. These two parentheses here. The second one has a negative in front of it, so we need to distribute that negative. The first one isn't going to change, so we'll just have 1 minus 8I. And then that negative is going to make that -3 a positive 3. And then the negative is going to make the negative 4I a positive 4I. And then you just simply combine like terms. So we have 1 and a positive 3, that's going to give you 4. Then you have -8I and a positive 4I, it's going to give you -4I. And then you're done. Okay, so yeah, just combine like terms is all you have to do for these. If there's a negative in front of the parentheses, you just distribute the negative and then combine your like terms. Now, multiplying imaginary numbers is different because you're going to get an I squared, and that can change some things. So I'm looking at number 7 here. If I have anything in parentheses squared, what does squaring something mean? It means multiply it by itself. So I'm going to multiply -3 minus 8I times -3 minus 8I. So I'm going to multiply those two binomials together, and to do that, you distribute. So -3 times -3 is going to be a positive 9. -3 times -8I is going to be a positive 8 times 3 is 24. Keep the I. Then we have this -8. -8I times -3 gives you another positive 24I. Then we have -8I times -8I. It's going to be a positive 64. I times I is I squared. So whenever you multiply I times I, you get I squared. So combine your like terms. So we have 9 plus 48I plus 64I squared. But remember, what did I say about I squared? I squared is equal to -1. So I'm going to turn this I squared into -1, which is going to change that 64 into -64. And then everything else comes down. And combine your like terms with the 9 and the -64. So 9 minus 64. So that's going to give us -55 plus 48I. And there is your answer. So whenever you do any of these problems with I, you should always have a number with I. One of those numbers could be 0, but you should never have an I squared in your answer. So I'll do number 8 here real quick. So it's the same idea, it's just already set up to distribute. You don't need to, it's not squared, it's just multiplying by a different one. So we have 6 times 7 is 42. 6 times negative I would be negative 6I. 6I times 7, positive 42I. 6I times negative I is going to be negative 6I times I, so I squared. And then you combine your like terms, and this I squared, remember, is negative 1. So what he's going to do is change the sign of this. So instead of negative 6 is going to be positive 6. So I'm going to drop down to 42, negative 6 plus 42. So 42 minus 6. It's going to be positive 36I. And then remember that I squared is making this positive 6, which gives you more like terms to combine. 42 plus 6, so 48 plus 36I. There you go. So numbers 10 and 12, you will end up with an I cubed. So if I squared is negative 1, what does I cubed equal? Well, I cubed is I squared times I. Right? So I squared is negative 1, so I can just say this is negative 1 times I, which is just negative I. So it doesn't matter what your exponent is on your I, you can always break it down into squares, which will break it down into negative 1s. Okay, so yeah, think about numbers 12, 10 and 12, those are good ones. The last 4 here are just simplifying square roots. So this is like when you're doing the quadratic formula, you want to take this number, check if it square roots. If it does not, then start dividing it by perfect squares, such as 9. Right, so then 27 can become the square root of 9 times the square root of 3, and then the square root of 9 becomes 3. Keep whatever's in that square root in there, and then you've got it simplified. So you want to divide by a perfect square, and then square root the perfect square, and leave the non-perfect square in the square root.